Hey there! Welcome to our calcbond introductory webinar. In this video, we'll show you the most important features of the platform to help you design better adhesive joints. The three main topics we'll talk about are the analytical toolbox, the auto FEA module, and the material cards section. Using the analytical toolbox, you can quickly perform analytical calculations to determine the stress distribution in the adhesive layer of a mechanically loaded single lap joint. The Auto FEA module lets you conduct a more detailed 3D analysis of standardized joint configurations, like a bonded stud, making use of the powerful finite element method. Both modules provide results not only in the user interface, but also as extensive PDF reports that you can save and view offline or share with colleagues, supervisors, or clients. In the material cards section, you can look up the most important engineering properties of adhesive products from renowned manufacturers like Sika to help you select the best suited adhesive for your application. In the end, we'll also take a quick look into the platform's wiki section, where you'll find a knowledge base with the most important aspects to know about adhesive technology. So to begin with, let me show you how to gain access to the platform. As calcbond is a completely browser-based application, just go to www.calcbond.com to register for a non-binding 30-day free trial, where you can explore all of the platform's features. After setting up your account, you'll receive an email asking you to confirm your registration. Once confirmed, you can log into calcbond using your credentials. After your first login, make sure to enter your correct company data to finish the registration process. Then you're all set to explore the app. Alright then, let's move on to the first feature, the analytical toolbox. Here we are in the user interface of the analytical toolbox. You can select between three different joint configurations, each representing different variations of a single lap joint with a rectangular bond surface of constant thickness. Select a configuration by clicking inside the box. You can also hover over the small info icon to read more about the feature and how it can be used. Next, the parameter input section will open up underneath. Here you can enter all the design parameters of your joint. Select your adherent and adhesive material from a predefined list, or simply enter your own values. This module uses the basic mechanical properties like the Young's modulus, the Poisson ratio, and the tensile strength for calculation. For the adherence, you can choose between isotropic materials like steel or aluminium, or generate a simple fiber-reinforced composite layup using standard fiber and resin materials. Next, enter the geometric parameters of your joint, like adherent and adhesive thickness and length, and the joint width. Last, enter your mechanical loads in the lower right box. In this case, the joint can be loaded with a horizontal shear force, a vertical peel force, and a bending moment on the right side of the adherent. You can apply all of these loads separately or combined in any way. Once you're happy with your input, click on the big blue Calculate Stresses button at the bottom, and the tool will instantly calculate the adhesive stresses and show you the calculation results in the interface. A new section will open up at the bottom, showing 1D plots of shear and peel stress distribution in the adhesive layer along the bond length. Also, a plot showing the failure criteria for cohesive failure, so pure rupture of the adhesive, is generated. This plot shows the so-called inverse reserve factor distribution. These inverse reserve factors are calculated as a ratio of equivalent stresses and the tensile strength of the adhesive material. You can read more about the failure criteria in the wiki section. Move the Set IRF Limit slider to visualize your threshold for maximum allowed IRFs in your adhesive layer. If you want your joint to fulfill a safety factor of, for example, 2, move your slider to a value of 0.5. Then you can see which parts of your bond length are exceeding this allowed IRF limit. After viewing the results online, you can request and download a PDF report summarizing your calculation input and results in a nicely laid out and clickable document. For this, simply click on the blue button on the right side saying Request PDF Report. The PDF report gives you all the relevant info of your adhesive joint calculation in a structured document. It contains the geometry and loading parameters, information on the used adhesive, as well as calculation result plots and tables. On the last page, you'll find links to the platform as well as your specific calculation online that can also be accessed by other calcbond users if you choose to share this report with them. If you want to save your calculation, do so by clicking on the Save Calculation button on the left. Make sure to give it a proper description by filling out the project and title text fields. You can find and reopen this calculation under the Save Calculations tab in the navigation bar. If you want to calculate more complex bonding geometries and also account for thermal effects due to high or low temperatures, you can do so using the AutoFEA module, which we'll check out next. So here we are in the AutoFEA module of calcbond. This module lets you calculate more complex joint configurations of standardized bonding applications using the 3D finite element analysis. The finite element method is a powerful numerical method to solve complex mechanical problems where simple design formulae fail to provide sufficiently precise results. This feature currently offers solutions for 5 different bonding applications. To start off with one of the use cases, simply click inside the box. Next, the input section to enter the joint parameters opens up underneath. For this video, let us analyze a simple steel fastener bonded to an aluminum plate. In the first box, enter the geometric parameters describing the fastener and the plate. The drawings help you associate the input fields with the respective measurements. You can position the fastener anywhere on the plate by changing the stud position input fields, or just click on the blue button below to center it. Next, enter your adherent and adhesive materials just like in the analytical toolbox. In the following box, you can now define your loading situation of the bonded stud. You can choose between a direct or remote loading. The remote loading configuration lets you place a remote force taking into account the lever distance of the load's origin to the stud. This can be useful to simulate the weight load of a heavy device attached to the stud when its center of gravity is far away from the joint. On the right side, enter your forces and moments and define the position of where the loads act on the stud. Use the drawing on the left to see how the parameters work. In addition to the analytical toolbox, you can now also enter a temperature difference acting on the joint. This thermal load will induce thermal expansion in the adherence and the adhesive layer. Also, the temperature-dependent mechanical properties of the adhesive will be accounted for if the material is selected from the material cards database. After you have defined the loading situation of the joint, we now need to define the boundary conditions, meaning the supports of the plate that the fastener is bonded to. Each side of the plate can be supported individually. Select between no support, sliding support, simple rotational support, or a completely fixed support. Change the support types by clicking the respective boxes. The text underneath will show you which degrees of freedom are affected by the support type. The tool will automatically check if your supports are fully defined prior to the calculation in order to prevent free body motion. Then your joint is fully defined and ready for calculation. Click on the Request Calculation button to send off the calculation job, which is then processed by our server. The job will be queued and simulated as soon as possible. Usually, it'll take no longer than 5 to 10 minutes until you can view your simulation results online. In case of a large amount of queued requests by other users, it could sometimes take a little longer. Once the simulation is finished, you can view the results online. The results section will open up underneath the input section. The first 2 boxes provide an overview of the FE model parameters. If you are familiar with FEA, this data helps you assess the quality of the generated model. On the right side, you have a summary of the maximum occurring stresses in your joint. Further below, you'll find 3D result plots of the joint showing the deformation as well as the stress and strain distribution of the entire joint. There also is an isolated view on the stresses and strains in the adhesive layer. Here, the red spots indicate the highly stressed areas. Each AutoFEA calculation is automatically saved in your Saved Calculations area, so no need to save it manually. You can, however, change its project and title tags in the overview table of the Saved Calculations section. Again, you can download a PDF report of your calculation by clicking on the blue button on the right. The PDF report is laid out in the same way as the Analytical Toolbox reports, however, the results section is of course a little more detailed. If you want to quickly start a new calculation with the same or just slightly different input data, click on the Transfer to New Calculation button at the bottom. The interface will then open up again and transfer your old input data to a new calculation set. We are now in the Material Cards section of calcbond, where we can take a look at application and engineering data of products from renowned adhesive manufacturers. For example, a range of material cards from Sika adhesives are hosted in this database. The overview table shows all available products of the respective manufacturer. If you want to view and compare them, click on the checkboxes on the right end of the table. You can select up to 5 different products. Then, click on the green button to open up the material cards below. Now you can see the material cards for each of the selected products. The left column stores basic product information and some physical properties at room temperature. On the right side, mechanical properties at different temperatures are shown. You can click through these temperatures using the vertical tabs on the right. Click through the horizontal tabs at the top left to switch between the adhesive products. For Sika adhesives, a substrate suitability matrix provides an overview of feasible material combinations of adhesive and adherent materials. This quickly helps you to assess which adhesive is suitable to bond certain types of substrates. If you want to quickly jump to an analytical calculation using one of the adhesives that you have just viewed here, click on the green button Submit to Join Calculation in the left column. The Analytical Toolbox interface then opens up, where you can then click on one of the configuration boxes to see that your selected adhesive has already been defined as input. As mentioned in the beginning, calcbond also offers its own wiki section to help users refresh or extend their knowledge on adhesive technology and joint calculations. Here in this section you will find information about adhesive technology basics, as well as the calculation methods and failure criteria implemented in calcbond. Also, design process rules according to relevant standards are summarized in schematic drawings to help you get an overview of which steps to take when designing your bonded joint. We are continuously developing further content to expand the knowledge base and provide users the best guidelines and support in their adhesive bonding tasks. So, that's it for our introductory webinar about calcbond, the new ecosystem for adhesive joint design. We hope you enjoyed the quick tour through the main features of the platform to help you get a sense of how you can best leverage its potential for your adhesive bonding applications. With calcbond, you can quickly and easily perform adhesive joint calculations to validate your design and boost your decision-making without the need for tedious and time-consuming research. Feel free to register for a 30-day free trial and check it out yourself. Visit www.calcbond.com and sign up today.